Okay, here's another problem where we're going to use some of the two-angle formulas. Let's just look at the questions. They want to know the sine of alpha plus beta, cosine alpha plus beta, sine alpha minus beta, tangent alpha minus beta. So there's going to be two angles involved in this problem, alpha and beta. Now up here, they give information about those two angles. If you can see that, it says the tangent of alpha is negative 3/4, and they tell us alpha is greater than square root of 2, greater than pi over 2 and less than pi. This is basically telling us which quadrant alpha is in. So this is in quadrant 2. Then here's beta. They give us a trig function for beta, sine of beta square root of 3/2. And they tell us beta is between 0 and pi over 2, which is quadrant 1. So then I'm going to approach this problem. We're going to need trig functions for both these angles. I'm going to take, for alpha, I'm going to take this trig function and create a right triangle. I'm going to take this trig function for beta and create a right triangle for beta. And then I can go in and start using all these formulas to do the calculations. So let me get a separate sheet of paper and write this down, because this is going to be a fair amount of work. So let's do alpha first. I'll even label it alpha up here. Tangent of alpha, negative 3/4, and we know it's in quadrant 2. So tangent SOHCAHTOA, though I'm not really worried as I create my right triangle, I'm not worried about this negative here. I just want to get the three sides of the triangle. So if this is alpha TOA, opposite over adjacent. Now Pythagorean formula, this is a very common right triangle because I know the hypotenuse is going to be 5. And I'll write it up so don't forget it. This angle is in quadrant 2. I'll do the same thing for beta, where the sine of beta is square root of 3/2. So SOHCAHTOA, so if I create a right triangle for beta, opposite over hypotenuse. Now this side down here, use a Pythagorean formula, hypotenuse squared minus this leg squared. Square root of 3 is going to be 3. Square root of 1 is just 1. So this side down here is 1. And this angle beta is in quadrant 1. So now, part A said, what is the sine alpha plus beta? So I'll simply go to my formula sheet. And I use this formula. So it's going to be sine of alpha times cosine of beta plus cosine of alpha sine of beta. Now I can go, here's a right triangle for alpha, here's a right triangle for beta, and I can just go get the values. Sine of alpha, alpha, sine, opposite or hypotenuse, I'm in the second quadrant, sine is positive, There's the sine of alpha. Cosine of beta. Here's my beta triangle. Cosine, so ca, adjacent over hypotenuse. In the first quadrant, cosine's positive, so there we go. Cosine alpha. So ca, adjacent over hypotenuse. 4/5 in the second quadrant. It's negative 4/5. And then sine of beta. Here's the beta. Sine is square root over 2. And now I just do the calculation. This looks like 3/10. I got negative here, so it's minus 4 square root of 3 over 10. And then for the final answer, they might want you to combine these together. So this is number 64. And this answer is correct. They wrote it as one fraction, but I'll just leave it like that. How about the next one? The next one said cosine alpha plus beta. Once again, I got my formula sheet. Formula for cosine, adding two angles, cosine, cosine minus sine, sine. Cosine, cosine minus sine, sine. Cosine of alpha, here's alpha, so ca, negative 4/5. Cosine of beta, so ca 1/2, positive 1/2. Minus sine of alpha, 3/5. It's positive 3/5. Sine of beta, square root of 3 over 2, positive. Looks like minus 4/10 minus 3 square root of 3 over 10. And this is also correct, written as one fraction. Third one, sine alpha minus beta. For the formula sheet, alpha minus beta. Sine cosine minus cosine sine. So sine alpha times cosine of beta minus cosine alpha times sine beta. Sine of alpha, I can actually look up here because it's actually the same thing except instead of a plus it's a minus. So if I look here, actually it's the same calculation except I put a minus here. So really I can say it's going to be 3/10 instead of minus here, should be plus. Because you notice these two equations are identical except here you're adding, here you're subtracting. So, unless I messed up or confused, this should be the answer, and that is correct. Then the last one, tangent alpha minus beta. Tangents can be a little messy. We look here, ends up being a fraction. So it's going to be tan u, tan alpha minus tan beta over 1 plus tan alpha times tan beta. So tangents are opposite over adjacent TOA, opposite over adjacent. Quadrant 2, you can see first negative 3/4, so negative 3/4 minus tangent of beta, TOA, opposite over adjacent, so it's just square root of 3. 1 plus tan alpha times tan beta. So this is one where there's probably some major simplifying that we're going to have to do. What do we do? Let's combine these into one fraction, multiply top bottom by 4. So minus 3 minus 4 square root of 3 over 4. Here, common denominator is going to be 4, so if I multiply this is 4 minus 3 square root of 3. Now the 4's cancel, so I'm left minus 3 minus 4 square root of 3 over 4 minus 3 square root of 3. Now normally they don't like this in the denominator, so to rationalize it, it seems crazy, but it is what it is. So the bottom is easy, use a shortcut. This is going to be 16 minus 9 times 3, 27. Now the top, negative 12 minus 9 square root of 3 minus 16 square root of 3. This is going to be minus 12 times 3. So this is minus 12, this is minus 36. So that's minus 48 minus 25 square root of 3 over negative 11. All these negatives cancel. So amazingly enough, this is the correct answer. Pretty messy. All right. Now here's another one. It's actually not as difficult because you're going to see why in a minute. They say if sine theta is 2/5 and theta is in quadrant 2, find the exact value of. So now here we have some more sum and differences, but you notice the second angle is an actual angle. We don't have to jump through any of these hoops. The first angle, theta, comes from here, but then we have all these second angles. So what I'll do, I might have room to do it here. I need to still go build a right triangle so I can figure out what the trig functions of theta are going to be. So if the sine is 2/5, so it's opposite over hypotenuse. This would be square root of 25 minus 4. Looks like it's going to be square root of 21. Now, well, this first one's not even it's just the cosine. So let's write here, it says it's in quadrant 2. So the cosine of theta, so cot, adjacent hypotenuse, square root of 21 over 5. But because it's in quadrant 2, it has to be negative. Now here's where we're going to use our addition formula. Once again, the sine of two angles, sine cosine plus cosine sine. So this is going to be first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. So what we do is, for these theta trig functions, we go to our right triangle. The sine, I can get it from here or over here. Either way, it's 2/5. Cosine of pi over 6. That's just from the unit circle. Cosine of pi over 6 is square root of 3 over 2. Plus cosine of theta. We know it's negative. Times the sine of pi over 6, 1/2. Now it looks like we're having a common denominator of 10, so I may be able to skip some steps and just write, it's like 2 square root of 3 minus square root of 21. And that is correct. So now the cosine, we're subtracting theta minus, so the cosine difference formula, cosine, cosine plus sine, sine. Cosine theta times cosine pi over 3 plus sine theta times sine pi over 3. Now, cosine theta, we've done it a bunch of times, is now negative square root of 21 over 5. Cosine pi over 3 from the unit circle, that's just 1/2. Sine theta is 2/5. Sine of pi over 3, square root of 3 over 2. So now once again looks like a common denominator of 10. This looks like negative square root of 21. This is like 2 square root of 3. How about I write it this way? 2 square root of 3 minus square root of 21. That's correct. And then the last one, tangent. Theta plus pi over 4. Tangents are always more of a mess. Let's just write this out. So it's going to be tangent of theta plus tangent pi over 4 over 1 minus tangent theta times tangent of pi over 4. Tangent of theta, here's our theta triangle. It's TOA, opposite over adjacent in quadrant 2. So it's going to be 2 over square root of 21, and it's going to be negative. Tangent of power 4 is just 1. 1 minus tangent of theta is negative 2 square root of 21 times 1. Now it's a matter of simplifying. If I combine these into one fraction, it's going to be 1, it's going to be square root of 21 minus 2 over square root of 21 over square root of 21 plus 2 over square root of 21. These square root of 21s cancel out. Square root of 21 minus 2 over square root of 21 plus 2. I need to rationalize this, so multiply top and bottom by square root of 21 minus 2. The bottom, I can do a shortcut. It's just going to be 21 minus 4. So this is going to be 21 minus 4 square root of 21 plus 4. So hopefully you get 25 minus 4 square root of 21 over 17. And thankfully that is correct.